Network Accessed Storage (NAS). In this video, we are going to learn about Network Accessed Storage (NAS). Network Accessed Storage (NAS) is also known as Network Attached Storage. Network Accessed Storage (NAS) is a dedicated hard disk storage device that is set up with its own network address and provides file-based data storage services to other devices on the network. A network attached storage device is attached to a local area network and assigned an IP address, allowing both application programming and files to be served faster because they are not competing for processor resources. NAS devices are usually configured with a web browser and do not have a keyboard or display. Like traditional file servers, NAS follows a client-server design. A single hardware device, often called the NAS box or NAS head, acts as the interface between the NAS and network clients. They generally run an embedded operating system rather than a full-featured network operating system (NOS). One or more disk and possibly tape drives can be attached to many NAS systems to increase total capacity. Clients always connect to the NAS head, however, rather than to the individual storage devices. Evolution of Network Accessed Storage (NAS). In this video, we are going to see evolution of Network Accessed Storage (NAS). In the past, floppy drives with capacities in more KBs were widely used to share data files. Over time, the need for larger and larger capacity has emerged due to growing need for data to be shared across organizations. Removable storage media, such as flash drives, are capable of storing gigabytes (GB) of data, have now complemented the traditional removable media drives. Businesses not only need the capacity to handle huge data storage requirements, the need to share their data has made network attached storage (NAS) an attractive option. NAS systems use external storage for server hosts, adding flexibility to network storage. NAS works at the file level rather than the block level. This enables widespread access to the data over the network based upon the file system client loaded. General purpose servers versus NAS. This video explains about general purpose servers versus NAS. Unlike a general purpose server such as a Unix or NT server, a NAS server is a device optimized for file serving functions such as storing, retrieving, and serving files. A single function NAS device provides real-time OS dedicated to file serving, open standard protocols, built-in native clustering for high availability. Components of Network Accessed Storage (NAS). In this video, we are going to learn about components of Network Accessed Storage (NAS). The following three components play an important role in NAS: NAS connections, NAS protocols, NAS drive. NAS connections. Connecting a NAS to your network is simple by plugs into your network router with a network cable. If you have a wireless router, that means you can access your NAS wirelessly from anywhere within range. NAS allow you to put all your files in a single server location that gives you access them from any of your computers or devices. Different mediums are used for establishing connections with NAS servers, including Ethernet, fiber optics, and wireless mediums with 802.11 standards. NAS protocols. There are several network protocols used to access data on a network-attached storage device. They are Secure Copy Protocol (SCP), File Transfer Protocol (FTP), Transmission Control Protocol, Internet Protocol (TCP/IP), Hypertext Transfer Protocol (HTTP). NAS servers are fully supported by the Network File System and Common Interface File System. NAS also support different kinds of network protocols, including Secure Copy Protocol (SCP) and File Transfer Protocol (FTP). However, over Transmission Control Protocol or Internet Protocol, that is TCP/IP, communication can be done more efficiently and reliably. The initial purpose of NAS design was only file sharing over Unix across a LAN. NAS also strongly supports Hypertext Transfer Protocol (HTTP), so users or clients can easily download the stuff directly from the web if NAS is connected to the internet. NAS drivers. NAS has at least one hard drive, and you can keep adding more hard drives for more storage. Addition to it, NAS also has a single hardware device, often called the NAS box or NAS head. NAS even allow you to securely access your files over the internet when you are not in home. Any technology can be used for this purpose, but Small Computer System Interface (SCSI) is used by default. ATA disks, optical disks, and magnetic media are also supported by NAS. Benefits of network accessed storage. In this video, we are going to see benefits of network accessed storage. NAS offers a number of benefits which address some of the limitations of directly attached storage devices and overcome some of the complexities associated with SANs. NAS benefits includes the following: resource pooling. A NAS appliance enables disk storage capacity to be consolidated and pooled on a shared network resource at great distance from the clients and servers which will share it. Thus, a NAS appliance can be configured as one or more file systems, each residing on specified disk volumes. Exploits existing IP network infrastructure. Because NAS utilizes the existing LAN infrastructure, there are minimal costs of implementation. Staff with existing skills in IP networks can carry out the installation. Simple to implement. Because NAS devices attach to mature, standard LAN infrastructures and have standard LAN addresses, they are typically extremely easy to install, operate, and administer. This plug-and-play operation results in low risk, ease of use, and fewer operator errors, so it contributes to a lower cost of ownership. Enhanced choice. The storage decision is separated from the server decision, thus enabling buyers to exercise more choice in selecting equipment to meet their business needs. Connectivity. LAN implementation allows any-to-any connectivity across the network. NAS appliances may follow for concurrent attachment to multiple networks, thus supporting many users. Scalability. NAS appliances can scale in capacity and performance within the allowed configuration limits of the individual appliance. However, this may be restricted by considerations such as LAN bandwidth constraints, and the need to avoid restricting other LAN traffic. Heterogeneous file sharing. A major benefit of NAS is support of multiple client file systems. Most organizations support mixed platform environments such as Unix and Windows. Improved manageability. By providing consolidated storage which supports multiple application systems, storage management is centralized. This enables a storage administrator to manage more capacity on a NAS appliance than typically would be possible for distributed storage directly attached to many independent servers. Enhanced backup. NAS appliance backup is a common feature of most popular backup software packages. Reduced total cost of ownership. Because of its use of existing LAN network infrastructures and of network administration skills already employed in many organizations such as Tivoli NetView Management, NAS costs may be substantially lower than for directly attached or SAN attached storage. NAS has 4 benefits: store, share, backup, protect. NAS lets you keep all your documents and media files in one central place, so they are always ready to use and enjoy no matter which computer or devices you are using. NAS allow you to share files with people outside your own network. NAS makes it simple to backup your files. The content of all the computers on your network can be copied to the NAS on a regular schedule. NAS keeps your files safe and secure. You can set up with great precision that which computer and users can access different files and folders on the NAS. NAS has a security technology that prevents unwanted intruders from gaining access to your files. Drawbacks of network accessed storage. In this video, we are going to see about drawbacks of network accessed storage. The file transfer speed is not as fast as DAS, direct attached storage. For using NAS device, user should know some basic knowledge about computer networking. System available features depends upon the NAS chip and firmware. While storage management facilities on NAS filers have gotten a lot better, especially with the release of Windows Storage Server, NAS filers still lack the sophisticated management tools available for SANs or high-end NAS systems. Heavy use of NAS will clog up the shared LAN, negatively affecting the users on the LAN. Cannot offer any storage service guarantees for mission-critical operations since NAS operates in a shared environment. Storage area network. In this video, we are going to see storage area network. A storage area network (SAN) is a collection of storage devices that are tied together via a high-speed network to create one large storage resource that can be accessed by multiple servers. Storage area networks are composed of hardware and software. The hardware are the physical storage devices which has strong interconnection rate for faster transfer. The software part of SANs are the monitoring of the networks and its configuration. It is also responsible for organizing the data of the network. A storage area network (SAN) is a separate network dedicated to storage devices and at a minimum consists of one or more large banks of disks mounted in racks that provide for shared storage space which is accessible by many servers or systems. Other devices such as robotic tape libraries may be attached to the SAN. A SAN presents shared pools of storage devices to multiple servers. Each server can access the storage as if it were directly attached to that server. A SAN supports centralized storage management. SANs make it possible to move data between various storage devices, share data between multiple servers, and backup and restore data rapidly and efficiently. In addition, a properly configured SAN facilitates both disaster recovery and high availability. Evolution of storage area network. In this video, we are going to see evolution of storage area network. With the introduction of mainframes, computer scientists began working with various architectures to speed up I/O performance in order to keep pace with increasing server performance and the resulting demand for higher I/O and data throughputs. SANs represent the evolution of data storage technology to this point, traditionally on client-server systems. The data was stored on devices either inside or directly attached to the server. Next in the evolutionary scale came Network Attached Storage (NAS), which took the storage devices away from the server and connected them directly to the network. SANs take the principle one step further by allowing storage devices to exist on their own separate network and communicate directly with each other over very fast media. Users can gain access to these storage devices through server systems which are connected to both the LAN and the SAN. Components of storage area network. In this video, we are going to see components of storage area network. The physical components of a SAN can be grouped in a single rack or data center or connected over long distances. This makes a SAN a feasible solution for businesses of any size. The SAN can grow easily with the business it supports. The components of a SAN can be grouped as follows: fabric components, host components, storage components. Fabric components. All hosts connect to the storage devices on the SAN through the SAN fabric. The network portion of the SAN consists of fabric components such as SAN switches, data routers, cables, communications protocol. SAN switches. SAN switches can connect to the servers, storage devices, and other switches and thus provide the connection points for the SAN fabric. Data routers. Data routers are intelligent bridges between SCSI devices and FC devices in the SAN. Servers in the SAN can access SCSI disk or tape devices in the SAN through the data routers in the fabric layer. Cables. SAN cables are usually made of special fiber optic cables that are used to connect all of the fabric components. The type of SAN cable and the fiber optic signal determine the maximum distance between SAN components and contribute to the total bandwidth rating of the SAN. Communications protocol. Fabric components communicate using the communications protocol. FC is the storage interface protocol used for the most of today's SANs. FC was developed as a protocol for transferring data between two ports on a serial I/O bus cable at high speeds. Host component. The host components of a SAN consist of the servers themselves and the components that enable the server to be physically connected to the SAN. HBA's host bus adapters are located in the servers along with the component that performs digital to optical signal conversion. HBA drivers running on the servers enable the server's operating system to communicate with the HBA. Storage components. The storage components includes storage processor, disk arrays, tape storage devices. The SPs are the front end of the storage array. SPs communicate with the disk array, which includes all the disks in the storage array, and provide the RAID or LUN functionality. Working of SAN. In this video, we are going to learn about working of SAN. The SAN components interact as follows. When a host wants to access a storage device on the SAN, it sends out a block-based access request for the storage device. SCSI commands are encapsulated into FC packets. The FC packets are converted for transmission on the fiber optic cable. At the same time, the request is packaged according to the rules of the FC protocol. The HBA transmits the request to the SAN. Depending on the port used by the HBA to connect to the fabric, one of the SAN switches receives the request and sends it to the storage processor, which sends it on to the storage device and responds for the request. The remaining sections of this white paper provides additional information about the components of the SAN and how they interoperate. These sections also present general information on configuration options and design considerations. Difference between NAS and SAN. In this video, we are going to see difference between NAS and SAN. Network accessed storage. Use the same cabling as the cabling on the network they are connected to. Use network protocols TCP/IP, IPX or SPX and so on, and the file sharing protocols that is CIFS, NFS and so on to communicate with the network. Are easy to install and maintain, resulting in lower TCO. The file system is located at the NAS device, can support heterogeneous clients seamlessly, or slow compared to SANs. Storage area network. Use high-speed connectivity such as a fiber channel irrespective of the cabling used by the network they are connected to. Do not use any network protocols because data requests are not made over the LAN to which they are connected. Need considerable expertise to install and manage. As a result, they are expensive. The file system is located at the network segment. Special software is required to provide access to heterogeneous clients. Are faster than NAS. Advantages of storage area network. In this video, we are going to see advantages of storage area network. SAN architecture facilitates scalability. Any number of storage devices can be added to store hundreds of terabytes. SAN reduces downtime. We can upgrade our SAN, replace defective drives, backup our data without taking any servers offline. A well-configured SAN with mirroring and redundant servers can bring zero downtime. Sharing SAN is possible. As SAN is not directly attached with any particular server or network, a SAN can be shared by all. SAN provides long-distance connectivity. With fiber channel capable of running up to 10 kilometers, we can keep our data in a remote, physically secure location. Fiber channel switching also makes it very easy to establish private connections with other SANs for mirroring, backup or maintenance. SAN is truly versatile. A SAN can be a single entity, a master grouping of several SANs, and can include SANs in remote locations. Disadvantages of storage area network. SANs are very expensive as fiber channel technology tends to be pricier and maintenance requires a higher degree of skill. Leveraging of existing technology investments tends to be much difficult. Though SAN facilitates to make use of already existing legacy storage, lack of SAN building skills has greatly diminished deployment of homegrown SANs. So, currently, pre-packaged SANs based on fiber channel technology are being used among the enterprises. Management of SAN systems has proved to be a real tough one due to various reasons. Also, for some, having a SAN storage facility seems to be a wasteful one. Also, there are a few SAN product vendors due to its very high price and very few mega enterprises need SAN setup.